For a wave in a string, we have a function y of position and time. Y being the displacement of a point on the string. For a sound wave, we have a pressure at point x and t, and it's pressure that's being transmitted. This is a pressure wave. So the pressure takes the place of the displacement from equilibrium, and it's really the difference of pressure from equilibrium. Okay? And I guess this P of xt is really the pressure difference from equilibrium. The pressure as measured from the equilibrium or the gauge pressure or whatever. We have a cosine of omega t minus kx, which, as you've seen, propagates the wave. It's responsible for the propagation of the wave. And we have this expression here, which is called the pressure amplitude. And that pressure amplitude is just the bulk modulus times the wave number k times a, which is the, well, it's a constant. And this tells us the maximum difference of pressure from the equilibrium pressure. The intensity of the wave is its power per unit area. And in this case, if we do power over unit area, we get this expression. Note that it's proportional to omega squared a squared, just like any power. And takes these forms. Here again, rho is the mass density and b is the bulk modulus. Here rho is the mass density and v is the velocity. So the intensity could be expressed as the square of the maximum pressure difference from equilibrium divided by 2 times rho v, where v is the velocity, or the square of the maximum pressure difference over 2 times the square root of rho v. We have a measure of intensity, beta. The intensity of sound waves vary over an extremely wide range. We're going to say beta is 10 decibels times the log of an intensity ratio, where I is the intensity, which could be expressed like this, is often just given, and I naught is the threshold of hearing intensity. I naught is 10 to the negative 12th watts per square meter. And this intensity, of course, being power over area, is measured in watts per square meter. So if we have an intensity, we divide it by 10 to the negative 12th watts per square meter, take its base 10 logarithm, multiply it by 10, and we have what we call the decibel intensity of the sound.